Hi. Welcome to Inference. In this video, I will be talking about the quantum threat to Bitcoin. Quantum computing is a type of computing that is based on the principles of quantum mechanics, which is a branch of physics that studies the behavior of very small things like atoms and subatomic particles. In classical computing, a computer stores and processes information using bits, which are represented by either zeros or ones. Quantum computers, on the other hand, use quantum bits, or qubits, which can represent both zeros and ones simultaneously. This property, known as superposition, allows quantum computers to perform certain types of calculations much faster than classical computers. Another key concept in quantum computing is entanglement, which refers to the ability of two or more qubits to become connected in a way that their properties become linked, even if they are separated by large distances. This allows quantum computers to perform certain types of calculations that are not possible on classical computers. Overall, quantum computing has the potential to revolutionize many fields, including healthcare, finance, and materials science, by enabling the solution of problems that are currently too complex for classical computers to handle. Quantum supremacy refers to the point at which a quantum computer can perform a calculation that is beyond the capabilities of even the most powerful classical computers. Achieving quantum supremacy would be a major milestone in the development of quantum computers, as it would demonstrate that quantum computers are capable of solving problems that are currently unsolvable by classical computers. However, it is important to note that quantum supremacy does not necessarily mean that quantum computers are superior to classical computers in all respects. There will still be many types of calculations that classical computers can perform more efficiently than quantum computers. In addition, achieving quantum supremacy is a very challenging goal, and it is not clear when, or even if, it will be achieved. Scientists and engineers are actively working on the development of quantum computers, but there are still many technical challenges that need to be overcome before quantum computers will be able to perform calculations that are beyond the capabilities of classical computers. It is difficult to predict which entity will be the first to achieve quantum supremacy, as it will depend on a variety of factors, including the level of investment, the capabilities of the team working on the project, and the specific approach being taken to build the quantum computer. There are several organizations and companies around the world that are actively working on the development of quantum computers, including Google, IBM, and Microsoft, as well as various academic institutions and startups. Some experts believe that quantum supremacy could be achieved within the next few years, while others believe that it may take much longer. Ultimately, it is difficult to predict when, or even if, quantum supremacy will be achieved, as it depends on the progress made in overcoming the many technical challenges that are currently facing the field of quantum computing. Bitcoin is a decentralized digital currency that uses cryptography for security, and is not controlled by any government or financial institution. Transactions with Bitcoin are recorded on a public, decentralized ledger called the blockchain. Here's how it works. A transaction is initiated when one person sends Bitcoin to another person. The transaction is broadcast to the network of computers running the Bitcoin software. The network of computers verifies the transaction, using complex mathematical algorithms. Once the transaction is verified, it is recorded on the blockchain. The transaction is now complete. The decentralized nature of the Bitcoin network makes it resistant to fraud and censorship, as there is no central authority that can block or reverse transactions. Bitcoin can be bought and sold on exchanges, or it can be obtained through a process called mining, which involves using computers to solve complex mathematical problems to verify and record Bitcoin transactions on the blockchain. Miners are rewarded with Bitcoin for their efforts. Quantum computers have the potential to perform certain types of calculations much faster than classical computers, which could potentially be used to break the cryptographic protocols that are used to secure Bitcoin transactions. However, it is important to note that the development of quantum computers is still in its early stages, and it is not clear when, or even if, quantum computers will reach the level of computational power needed to break the cryptographic protocols used by Bitcoin. In addition, the Bitcoin community is aware of the potential threat posed by quantum computers, and there are already efforts underway to develop cryptographic protocols that are resistant to quantum attacks. These efforts are still in the early stages, but they are an important step in ensuring the long-term security of the Bitcoin network. Overall, while quantum computers pose a potential threat to the security of Bitcoin, it is not currently clear when, or even if, this threat will materialize. Several cryptographic protocols have been proposed as being resistant to quantum attacks, including hash-based cryptography. This type of cryptography uses mathematical functions called hash functions to create digital signatures. Hash functions are difficult to invert, which makes them resistant to quantum attacks. Code-based cryptography. This type of cryptography uses error-correcting codes to create digital signatures. Code-based cryptography is believed to be resistant to quantum attacks, but it is not widely used due to its complexity. Multivariate cryptography. This type of cryptography uses mathematical functions that are based on multiple variables, rather than a single variable, to create digital signatures. Multivariate cryptography is believed to be resistant to quantum attacks, but it has not been widely studied. Lattice-based cryptography. This type of cryptography uses mathematical structures called lattices to create digital signatures. Lattice-based cryptography is believed to be resistant to quantum attacks, but it is not yet widely used. It is worth noting that the development of cryptographic protocols that are resistant to quantum attacks is an active area of research, and it is not yet clear which, if any, of these protocols will be adopted as the standard for securing data against quantum computers. Alright, folks, that is it for this video. I hope you enjoyed it and learned something new about the quantum threat to Bitcoin. Thank you for watching. Have a good one. Goodbye.